additional exponent properties. The first is finding an exponent, the solution when we have an exponent of 0. It's very simple. Whenever we have any number to the 0th power, the answer is 1. Okay? So if you have any number a to the 0 power, it equals 1. So for example, if we have 5 to the 0 power, it equals 1. So here we have 2/3 to the 0 power. That is going to equal 1. Here we have -1 to the 0 power. That is going to equal 1. And last but not least, we have 5,307,126 to the 0 power. And you guessed it, that's going to equal 1. Alright, that is our first property for the day. So whenever anything is to the 0 power, negative number, fraction, really big number, really small number, to the 0 power equals 1. Okay? Our second property today is with negative exponents. Okay, so whenever you're simplifying something, you simplify it so that there are no negative exponents in the problem. Okay? So negative exponents work with reciprocals. Those of you who know what a reciprocal is, awesome. For those of you who don't, very quickly, when you have a number such as, c, the reciprocal of c is 1 over that number. Okay, the same thing can be said for when you have a fraction. So if you have a fraction like d over e, okay, the reciprocal of d over e, you're just going to flip them. So you have d over d. Okay? Either way, you want to look at it, it says the same thing. So it's just flipping a fraction. Alright? That's a quick recap. So here we have numbers with exponents. If we have a number to a negative exponent, okay, that is the reciprocal of that same base with a positive exponent. So if we're looking at a number with a negative exponent, if we want that negative exponent to become positive, we take the reciprocal of it. So we put 1 over that same base and the positive exponent. Okay, so this little negative right here does not mean it's a negative number, but that negative means the reciprocal. Okay? That does nothing to affect this number. If you notice, the bases are staying the same. It's just the location and the fraction of where it's at. It goes from numerator to denominator. Okay? So if you have 2 to the -1, the negative right here means reciprocals. We're going to put 1 over 2, and since we took the reciprocal, it is now a +1. Okay? Here it's just the same property, but in reverse. A to the positive n exponent is the reciprocal of a to the negative n. So if you have something that has a positive exponent and for some reason you want to make it a negative exponent, not really sure why, you would take the reciprocal of it. So a to the positive n is going to be the same thing as 1 over a to the negative n. Okay, so they work in a pair. So if you have 3 squared, that is the same thing as 1 over 3 to the -2. And these also work backwards. So if you are looking at 1 over 3 to the -2, to make that exponent positive, you're going to switch it from the denominator to the numerator, and that would make it a +2. Okay, so if you ever have a negative in a problem, in order to get rid of that negative in the exponent, just either flip it from numerator to denominator or denominator to numerator. Okay? Alright, so here for example number 1, we have 3 to the -2. Alright, again, this negative means reciprocal. It does not mean that 3 is negative. It means that the problem, we're taking the reciprocal of it. The base stays the same. So if we want to get rid of that negative, that means we take the reciprocal of it. So we go 1 over 3 squared, which 1 over 3 squared is 1/9. That's your answer. Okay? Example 2, we have 1/5 to the -3rd. Okay, this is a fraction. This, again, means reciprocal. So we can go ahead and take the reciprocal of what is inside that parentheses. The reciprocal of 1/5, if we flip the numerator and denominator, we get 5. So a way to look at that is 1 over 1/5 to the third. That means you're taking the reciprocal, or we could just go ahead and flip the numerator and denominator, which means that we're going to be taking 5 to the third. And 5 to the third is 125. Okay? If you know the definition of a reciprocal, you can go ahead and skip this step and just flip your numerator and denominator, and you would get 5 over 1, which is your 5 to the third. Okay? So you can skip this step if you would like. Alright, example 3. We have 1 over 2 to the negative third. So now we have a negative in our denominator. Okay, nothing changes. This negative still means it's a reciprocal. Okay, so if this is in my denominator, the reciprocal is going to push this up into the numerator. So instead of this being in the denominator, I'm just going to make it a positive exponent and send it to the top of my fraction. Alright, that's how the quick and easy way to deal with negative exponents. The base stays, and we just flip the location, whether it's from denominator to numerator, numerator to denominator. So this 2 to the negative thirds in the denominator becomes 2 to the positive third cubed in the numerator. And 2 cubed is 8. Okay? Alright, in our last example, we are going to apply negative exponents and some of our exponent properties. Okay, so we have 3 to the negative 2 power times 3 cubes all over 3 to the negative 4th power. Okay, now we can do this 2 ways. We're going to do way number 1 first, and then way number 2 second. Okay, the first way is that we're going to deal with our negative exponents. So, if this is a negative exponent in the denominator, to make it positive, I send it to the numerator. Okay, so if I send this guy to the numerator, that's going to give me 3 to the negative 2 times 3 cubed times 3 to the 4th. Okay, so this, I took the reciprocal and sent it to the numerator. So that's all over 1. Okay, the other one that I'm dealing with here is this negative 2 in the numerator. So to get rid of it, get rid of the negative, I'm going to send it to the denominator. So that's going to give me 3 cubed times 3 to the 4th over 3 squared. Okay, now I have all these positive exponents, and now I can use my exponent properties. So these are all the same bases. Whenever I have the same base and multiply together, I'm going to add exponents. So that's going to give me 3 to the 3 plus 4th power over 3 squared. 3 to the 3 plus 4th is 3 to the 7th over 3 squared. Now I'm dividing things with the same base, which means I can subtract the exponents. So that gives me 3 to the 7 minus 2 power, which is 3 to the 5th. Okay? That is way number 1 to do that problem. Way number 2 would be to just go ahead and jump right in to your exponent properties. Okay, so if we have the same problem, so we have 3 to the negative 2 times 3 cubed all over 3 to the negative 4. Okay, we can just jump into our exponent properties here. So we have the same base. So if we have the same base and we're multiplying it, what can we do? Add the exponents. So here we're going to have 3 to the negative 2 plus 3 all over 3 to the negative 4. Okay, negative 2 plus 3 is 1. So I'm going to have 3 to the 1 over 3 to the negative 4. Okay, now I'm dividing things with the same base, so I subtract the exponents. Keep the base, which is 3, and then I have 1 minus a negative 4. 1 minus a negative, that becomes plus, so 3 to the 1 plus 4 is 3 to the 5th, which would be the same answer. Okay? That is all for section 8.3.